So you have a choice. You're babysitting and you are going to decide, would you rather charge $5 for the first hour and $8 for each additional hour, or charge $15 for the first hour and $6 for each additional hour? So you come up with whichever one fits you best and why. And I'll give you time to do that. Use your calculator, use your notes if need be. You can talk to the people around you, see if you got the same thing or different and why. And I'll give you some time to work on that. Choose and why. Ella?
I would choose the second one.
Why?
Because if you're working 2 hours, you get $15 for the first hour and $6 for each additional hour, and choose 15 plus 6 1, which is the other hour. If you do it for the second one, if you do 5 plus 8 is 1, you only get 13.
Okay. So you're choosing the second, you're only going to babysit for like 2 hours and you get paid more for the second one?
Yeah.
Sorry.
Well, I babysit, and I babysit for an average of 6 hours. So, if you did the math, I would do the first one, because if you do the $5 plus the 8 times 6, you get $53. And for the second one, if you do the 15 plus 6 times 6, you get 51. So not only are you getting a better profit, but it would make them think that they're paying less when really they're paying more.
Wait, do you have something different?
Yes, I would have chosen the second answer because maybe my graph isn't exactly what I want it to be because I can't find the intersect point.
Okay.
But it seems that the price increases for the second one faster than it increases in the first one.
Okay. So it's talking about something we haven't really talked about yet. That would be like slope and things like that. Rate per hour. Okay.
And I don't remember how to find the intersect.
Okay. Anyone else have the second reason for a different option for a different reason? Terry.
Well, I would choose the second option because the second option, most of the time, parents usually value babysitters because they're growing out of date. So like 4 to 3 hours. So 4 to 3 hours would be more. If we're doing 15, that'd be more money than those for 2.
Okay. Do you have those numbers? It's okay if you don't.
I don't.
Anyone else have a different reason?
Oh,
Okay.
So for 4 hours, right? So if you do first 5 plus 8 times 4, you would only get 57. But if you do 15 plus 6 times 4, you get 39.
So it looks like this is the winner for lower amounts of time, maybe like a date night, short amount of time. But if you are watching them for like the parents went to work or something, 6 to 8 hours, you may be looking at something like this because this will eventually get you more money. So it depends on how long you're babysitting for and to get more money. Anyone else have a different reason or a different explanation? So it's all a lot of the same things. Some of us actually came up with the equation. Some of us were just kind of multiplying, adding, and making a list. All of you were kind of doing the same thing. Right, so good job on that. I used to babysit my siblings, but I did not get paid. But that's a whole other story. Okay, so we have new notes today on solving absolute value equations. So we talked about solving multi-step, we talked about word problems, and now we're on this part. This will be calculator. There's only really 2 things that are non-calculator. Some of the multi-step, some of it will be calculator, some will be non-calculator, and then literal equations, which is what we're going to do on Tuesday, that will be non-calculator. Okay, I'm going to have you guys fill out this part. So the steps to solve are very similar to solving a multi-step equation, but there are some slight differences. So we have to make sure the absolute value expression is isolated. What does that mean, to be isolated? by itself. Is that what you're saying? So we have to get it by itself. We'll explain how that works here in a bit. Set the inside equal to both the positive and negative number from the other side of the equation. I'll show what that means here in a second. Solve both equations, and then the final answer, you're going to write it as a solution set. It's going to look like this. X equals, in curly brackets, least to greatest. We are going to go through the problems. They're going to start off easy and get gradually harder as we progress through them. Anyone still need this one? Alright. So let's start at number 1. Make sure it's isolated. So the absolute value bars have to have nothing around it. It's already isolated. It's already by itself, so check on that. We don't have to do it. Then we're going to take whatever's on the inside. Well, first, we're going to drop the absolute value bars, so get rid of them. And we're going to set this equal to a positive 2, and we're going to set it equal to a negative 2. Remember that absolute value measures distance, so it can equal a positive and a negative. If these were equations, we would solve them, but they're not. So we basically have our answers, and then we can write them as a solution set. Least to greatest, negative 2, 2. When you have the same number, just one's positive, one's negative, you can also write it like this. So curly brackets, this is plus or minus, is how you say the symbol, and then just put a 2. It just means negative and positive 2. No, it's the curly bracket. I just can't do this one. I keep trying, but it's like, it doesn't do it. So I just, sure, whatever.
How'd you put negative 2 again?
Oh, here. So it's just something we have to do in the steps. Because absolute value measures the distance, so it could be measuring the forward distance and the backward distance, so we have to take account both. Yeah. Yes. Other questions on that one before we move on?
So it's least to greatest.
Least to greatest. Unless you're writing it like this, then it's plus or minus.
Does it matter if you use a curly bracket or just a regular?
Yes, so if we use parentheses, that would make this an ordered pair. We don't want that. So it has to be curly brackets to say it's a set of numbers. Okay. Number 3. Same process. Make sure this is isolated. It is, so check on that. Drop the absolute value bars. Set this equal to a positive 40 and a negative 40. We have equations, so we can solve them both by dividing by 5. So in this case, we would get another positive and negative version of the same number. That's not always the case, but sometimes that happens. You don't need to write both, but if you would like to write both, you can. Questions on that one before we move on? Now let's try 5 or 6. I'll let you guys choose. So for number 6, rules are the same. Isolate the absolute value if there were anything out here, but there is nothing, so check on that. Drop the absolute value. Set this equal to a positive 4 and a negative 4. And then we're solving for W, so we would do what in this case? Add 3 to all the sides. We have W equals 7 and W equals negative 1. So this would be a case where the numbers are different. So So we can't use plus or minus here because the numbers are different. Do you have any questions on that one? And then let's do 7 or 8. I'll let you guys choose.
8.
Okay. So for 8, same rules. There's nothing outside of the absolute value bars. Drop them. Set it equal to a positive 17 and a negative 17. Notice that we did not change the negatives that were inside. That's not what we're doing in this one. So when we were evaluating, we would drop them. Well, there would be nothing else left to do, and we would make it positive. But because we're solving to figure out what the variable is, we are not doing that here. Okay, so how would we solve this? 5. We have 22 and negative 2b equals negative 12. And then divide everything by negative 2. So we get negative 11 and positive 6. Do you have any questions on how we did 8? Or any of the questions that we skipped over on this video? We're going to go on to the next page if there aren't any questions on this page. So all the examples we just did had nothing outside of the absolute value bars, but now these ones will. So we're going to have to isolate the absolute value bars. And when we do that, we have to think about it like whatever's inside the absolute value bars, treat that entire expression as like x. We're trying to solve for that, but we're going to leave that for the end. And then we get rid of anything outside. So how would we get rid of the plus 2? Subtract 2. Keep this in absolute value bars until it's been isolated. Once it's isolated, then you can drop it, set it equal to the positive and negative, solve it if necessary, and then write your solution set. Questions on that one? So plus or minus just means negative 10 and positive 10, but combined into one. Right. Let's try 11. We have to get the absolute value by itself. How would we get rid of 6? So divide, because this is multiplication, so we would have to divide both sides by 6. Then we don't have anything else, so we can drop the absolute value, set it equal to a positive and negative 4, and write your solution set. Let's try 12. What would be our first step? Divide both sides by negative 2. We have z plus 3 inside the absolute value bars equals 7. And then what? Drop the absolute value. value and do what? Make this equal to negative and positive 7. The order in which you put that does not matter. I just always write positive to negative. Okay. And then you can solve for z by subtracting. We would have z equals negative 10 and 4. Questions on the ones we've done so far?
I was gonna ask about 13.
Okay, and we'll do 13 this time. What was your question? What we
So for 6, we just multiply that instead of dividing.
Correct.
And now
Because
we
we're
just
all-
do it that way.
Yes, because we're already dividing, so multiply by 6 on both sides, and then yes, do the rest just like normal. Drop absolute value, 2w minus 4 equals 18, and set it equal to a negative 13. Okay, if you forget the negative version, you have lost half of your work and half of your answer. So make sure that you set it equal to both. And we can add 4 to everything. So 2w equals 22 and negative 14 and divide everything first. So that w equals what? Seven and 11. Right now, and then we'll do 14 when we get back from lunch. Do we have any questions about 13 before lunch? Alex? Yes. Later. 514. What would be our first step?
To add 10.
No, not add 10, sorry. Because this is multiplying into
divide by
it.
10.
If we did that, we'd have to divide everything by 10 so that this and this would end up becoming fractions. So that would not be a good first step.
So to add 3.
And then
Divide by 2.
negative, yes. Then we can drop the absolute value, set this equal to positive 8 and negative 8, and solve for each. So we would get 3 and negative 13, or in our solution set, negative 13. Do you have any questions on that process? Have you got those answers? Anything like that? I want you guys to try 15 and 16. You can work together if you would like. You only have like 5-ish minutes to work through that. Double check your answer with the people around you, see if you got the same thing. If you need help, raise your hand, I'll be around. You want to do, you're doing 15, Ellen? You want to do 16? Okay.
You're also right off to the side of the main one. And the blank space to the left.
Who else got negative 6, 2? Good, yeah, fix a couple things. So as you're solving this should still be in absolute value to show that you isolated it. Then you should have your two equations.
You'll need to change the thickness. In the 3 lines. And then tap again. Yep.
So for this one, you could have either wrote them as decimals, 0.5, 1.5, or left them as fractions, 1/2, 3/2. Who all got that as an answer? Do we have questions about 15 or 16? Anything in there? So they should both be positive. They should both be positive. Sometimes that happens, you end up with 2 negatives or 2 positives, not necessarily a positive and a negative. It's just whichever is smaller goes first. Other questions on 15 or 16? Okay. Let's talk about some special cases. So when you get something like this, so you isolated the absolute value and it equals a negative, you cannot solve this. You will get, if you were to check it, it wouldn't work. This is no solution. Or you can use this.
Right. So, yes, in one second.
So if your absolute value is isolated, it cannot equal a negative because in general, it doesn't just equal a negative. When we are solving this, we drop the absolute value before we set it equal to a negative, otherwise it wouldn't work. But sometimes you won't know that it's no solution until you start to solve it. So like this one, if we divided both sides by -3, then we end up getting it isolated and it equals a negative. Now we can no longer solve it. It's no solution.
So it can't equal a negative.
It cannot. The absolute value cannot equal a negative. No. So I'm going to go back and show you a couple of examples after I show you this. So that I explain about it. Okay, so the absolute value cannot equal a negative number once it's isolated. For the same reason it can't when we evaluate, because it measures distance. It wouldn't come up with a true solution, all of those things. Right, so I'm going to go back and show you a couple of examples where you may have thought that would have been no solution, but why it ended up working out. And then I'm going to show you how you can check yourself in Desmos, kind of talk through how you can check it in the calculator, and then I'm going to have you do some practice problems. Anyone still writing this down?
The no solution, right here, is going to be on the front.
So you have to recognize that once it's isolated, you can't solve it, and stop. Don't keep solving. Okay, so in some of the examples we did, like number 12 equaled a negative, but it wasn't isolated. But when we divided by -2, we got a positive, so that was fine, that worked. 14, same thing, it equaled a negative, but it wasn't isolated, and once we isolated it, it became a positive. So just because it equals a negative automatically does not mean that it's no solution. You have to isolate it and see, does it become a positive, or does it stay a negative, or does it become a negative? Those would help you find the special cases.
So it's not isolated when there's no number outside.
Correct. Does not.
So if it's like so negative or became negative, there's no solution.
Correct. So if it was already a negative and it's already isolated, it's no solution. If it became a negative after you isolated it, it's no solution. Either way. I'm going to show this in the calculator in Desmos. So doing it in the calculator would be the same.
Isolating is like when you get just the x, right?
You get just the absolute value by itself. So like getting rid of the 6 and the 7, this is just by itself. In the calculator, the way to check yourself is the same as multi-step. Put in whatever solutions you get, but you have to check both of them to make sure they both work. You would put each one in separately, so put the -6 in all together, put the 2 in all together with the absolute value signs, and it will give you a 1 or a 0. If you were solving one that was no solution and you put in a solution, it's going to give you a 0 every time on your calculator. In Desmos, I'll show you what happens.
Wait, how do you set it in?
So let's do this one. So 7, alpha window. I already copied it up. Work and the answers were -6 and 2. Let's do 6 equals second math. 26. So you would put in one, and then you would go back and put in the other. So if you got the incorrect answer, it would give you a 0. So it's really just like the multi-step. But you have to make sure they both work. In Desmos, it works like this. I'll put in that same one. 7, absolute value. Someone read that problem off to me. 4n.
Plus 8. Minus 6 equals.
You have to use x anytime you're in Desmos, otherwise it won't work. And then you can't tap on it to see the number, but it'll do just like the multi-step, give you lines, and you'll be able to zoom in or zoom out to see this is at 2 and this is at -6. So you can check yourself in Desmos that way. But if you type in something that has no solution, nothing will do. Just like your no solutions for your multi-step. So just be careful with that. Double check yourself with Desmos while you're practicing or at home, but remember you won't have Desmos on the quiz on the test. I want you to practice the following on the last page, front and back. So circle star these. Number 2, number 7, and then flip it over to the back. So number 2, number 7, flip it over to the back. Number 9, and then 13 through 16. So 2, 7, 9, 13 through 16. You can use each other, work with each other, use your notes, use Desmos, use your calculator.
Would you want to see the star ones?
Yes, I want you to do those ones. When you finish, raise your hand and knock and check. And then afterwards, you can work on Delta Math or then on your phone after that. Alright, if you need my help, raise your hand, I'll be around. Give me 2 seconds. You can move around.